Hey, curious minds! Did you know matter can exist in a ton of different forms? From ice to fire, stars to black holes. Today, we're exploring the different states of matter, and here's the exciting part: it's not just solids, liquids, gases, or plasma. Matter has some truly mind-blowing, lesser-known states too. Let's uncover the science of how everything around us behaves at the atomic level. Let's start with the basics: solids. In a solid, atoms are packed tightly together, almost like they're holding hands. They vibrate, but they can't move around freely, so solids have a fixed shape and volume. Think of a rock or an ice cube. You can try, but you can't change its shape unless you put in some real effort. Now, heating things up with liquids. In liquids, atoms are still pretty close together, but they can move around each other freely. This is why liquids flow and take the shape of whatever container they're in, though they keep the same volume. Pour water into a cup, and it takes the cup's shape, no questions asked. Next up, we have gases. Imagine molecules moving so fast that they can't stay in one place. That's what happens in gases. They don't have a fixed shape or volume, they expand to fill whatever space they're in. Just think of air, or the steam rising from your morning coffee. It's invisible and all around you. Ready for something even hotter? Let's talk about plasma. Plasma is an ionized gas, supercharged with energy, where atoms break apart into ions and electrons. You can see plasma in neon lights, and of course, in stars like our Sun. It's the hottest state of matter, and those particles are zipping around like they're in a race. But wait, there are even weirder states. At incredibly low temperatures, just a hair above absolute zero, we can create a Bose-Einstein Condensate, BEC. In this state, atoms slow down so much that they almost stop moving completely and start behaving like one giant superatom. It's like quantum magic, where individual atoms lose their identity and act as a collective entity. It's a state of matter that sounds like science fiction, but it's very real and has been observed in laboratories. And on the flip side, we've got Quark-Gluon Plasma, a state that's formed in extreme particle collisions, like those in particle accelerators. Here, the building blocks of matter, quarks and gluons, break free from their usual bonds, creating a hot, dense soup. This is what the universe was like just moments after the Big Bang, when quarks and gluons roamed freely in a chaotic and energetic environment. It's a state that scientists can recreate in a lab for tiny fractions of a second, giving us a glimpse into the earliest moments of the universe. But that's not all. There are even more incredible states to explore. Fermionic condensates, these are similar to BECs, but made from fermions instead of bosons. To further clarify, bosons are a class of subatomic particles that follow Bose-Einstein statistics. They are force-carrying particles that mediate fundamental interactions between particles, for example photons, gluons, W and Z bosons, and Higgs boson all are classified as bosons. On the other hand, fermions are building blocks of matter for e.g., electrons, protons, quarks and neutrinos. Getting back to fermionic condensates, when fermions are cooled to ultra-low temperatures, fermions pair up and behave like a superfluid, no resistance, no friction. It's a fascinating state with huge potential for quantum computing. Next up, superfluids. Superfluids are liquids that flow without any viscosity. Think about it, liquids that can flow without any friction, even climbing up the walls of a container. Helium-4 and helium-3 can both become superfluids at temperatures close to absolute zero, and it's a truly bizarre and mind-blowing phenomenon. Supersolids. Imagine a material that keeps its solid structure but also behaves like a superfluid, flowing without resistance. That's what supersolids do. This state is still being studied and is a mix of solid and fluid properties, something totally new in the world of physics. Time crystals. Time crystals are a groundbreaking discovery that break the rules of time. These materials oscillate without using energy, essentially moving in time at their lowest energy state. It's a phenomenon that sounds like science fiction, but researchers have created them in the lab, opening up possibilities for future technologies. Each of these states of matter pushes the boundaries of what we know about the physical world and shows how extreme conditions can lead to fascinating, mind-bending phenomena that go way beyond the basics of solids, liquids, gases, and plasma. If this sparked your curiosity, hit that like button, subscribe, and let us know in comments below which state you found the coolest.